Testing, testing, testing. Excellent. There we are. All right. Hi. Hi, Matt. Oh, no, I was working on it. Don't worry. He's got the recording box. The recording box? The recording box. What is the recording box? The recording box. Oh, you mean the live tag? Maybe? Anyway, hi everybody, Virtual Rook here. Today we're going to be very, very fascinatingly learning GD script. I actually don't know if this is going to be enjoyable for anybody, but I'm going to do it because I could stream whatever the hell I want. So, a box clip to you. Oh, this. That's the microphone. Yeah. I have two of them actually. I don't have the second one in. If I really wanted to get crazy, I could do this in stereo and make it that you can hear my voice based off of ear to ear. I have no idea what the fuck it is. All the streamers use it. Yeah, exactly. It's just a lapel mic. Anyway, getting me distracted. I finally got my medication sorted out. That's just important to talk about real quick. So if you don't know, there's a huge mix-up with like my pharmacy and with everyone. So my ADHD medication, I haven't had it in like a month. It's really sucked. And I still don't have it right now, but I should have it soon, they say. Makes you seem extra official. It does, right? God, I'm losing so much hair. It's terrible. Anyway, I'm getting off track again. So yeah, I should be more on track soon because I should have my medication soon, which is awesome. I have hit a roadblock in my virtual reality game development. I'm trying to learn VR game dev right now for Godot which I still think should be pronounced Godot, but whatever. I have gotten really far in it. I could show you guys actually, I guess. Some of you have already seen this, but give me a second. Here we go. Oh, I also need to mute that because you guys can't hear me whenever this is on. Sources. View. No. Okay. There we go. Now you should just hear my game audio, which is not. Let me see this. Okay, yeah, so this is where we're at so far in the game. It's going to be a shooting gallery based off of the bow and arrow shooting gallery from Ocarina of Time. Right now it's like heavily influenced by it, but it's going to be... I'm going to be swapping things out as I go to... How do I turn off the... I don't remember how to turn off gizmos. Anyway, I'm progressively making it more my own. So whenever I develop, because I'm more of a, artist, I like to put a bunch of art stuff in first, and then I figure out the actual, game, which is the backwards way to do it. You're not supposed to do that at all. It's a terrible way to do it. You should make your VIP, or MVP, sorry. You should make your MVP first, which stands for minimum viable product. That's what it's called, at least in the, game dev community, which I think silly, but that's okay. You're supposed to just do a gray box and work on the mechanics of your game to test to see if your game's even fun first. But the problem is I don't know how to program. And so I was like, well, to learn Godot, I'm going to start by just making something I think looks cool. So I've 3D modeled everything you're seeing. I did not texture everything you're seeing. A lot of these textures are from freetextures.com, if I remember correctly. I believe that's the name of the website. But they do a really good job. All of it's free, obviously. And this is a lot of stuff from their stylized section. It just looks really good. But I did model everything, and I did texture a lot of the things that I modeled. So I made these lamps, which are hanging off of hooks. a little dark, but you know, whatever. I made these doors, which I was trying to just kind of simulate something boxy and simple that you might expect to see in, you know, an old Ocarina of Time game. What else did I make? I made the bow, which is right here. Again, loosely based off of the bow from Ocarina of Time, but it actually has an animation put on it. Yeah. Which I can show you by going here and hitting play. That's it. So you'll be able to pull it back. That's the plan. So far, basically just doing a better version of the bow and arrow tutorial that I already have on my channel from whenever I did Unreal Engine. And there's so many reasons right now to be going for Godot. Unreal Engine, like I've said previously on other streams, they've just started to really not give a shit about VR, which really sucks for me as a VR developer. They just keep on adding all these really, really cool things like nanite and what do they call it? Megalights and lumen, all this cool shit. Like, would love to use it. But their VR scene or their VR content is still like years behind everyone else. It's even years behind Godot. Godot's like brand new. They just don't give you good tools to actually use for VR development, which sucks. And everybody's always like, oh, well, you could just get, what is it? Unreal Engine VR toolkit or whatever, I think is the name. No. It should be built in. They should be handling it. I shouldn't have to get anything third party. And the toolkit is like, here, wait, that makes more sense for them. I'm ranting, so I'm just gonna go back on face. The toolkit doesn't make any sense to install because you have to like fundamentally change the programming of how Unreal Engine works. Like, that's part of installing it. It like rewrites code for Unreal Engine. I don't like that. That's icky to me, because if it screws up while it's installing, you have to reinstall, you have to completely wipe Unreal Engine and then reinstall it. I don't know. It just feels icky to me. I'd rather use something that wants me to use it for VR. Plus, there's a lot more documentation then, right? That makes more sense. So a lot of people would say Unity. Unity is a great option. Unity has a lot of things that are VR based. A lot of the stuff they've been working on in the past couple of years, especially with Unity 6 now. They just did a lot of stuff that makes it seem like they give a shit about people that are working in VR, which is cool. Love that. Unity's a shit company. Sorry. They keep on fucking up really bad, and it's not okay. It's like super not okay. Like, I was just reading today that their biggest like issue that they did was this studio didn't even make enough money off of the product to hit their tier of Unity wanting money back. So the way that Unity works is it's free until you make a certain amount of money, and once you make a certain amount of money off your product, then you have to buy seats, and you're a company then or whatever, and then you start paying them. And that's fine, that's whatever. But it would be fine if that's the way that it worked. The way that they basically told this company, who made way less than the amount that you need to make, I think it's like in the millions. You have to make somewhere in the millions in order for them to start asking you to buy seats and stuff. No, didn't even come close to millions. And Unity was like, you have to start buying seats. And they're like, why? And if I'm understanding correctly, it's because the people who bought their product or are using their product have more money, or like make more money. Something dumb like that. So like the company isn't making more money, but the people that are using the company's product that they've made using Unity make more money, or are using it to make money somehow. And so now the company that isn't making very much money, who made the product originally, has to pay Unity like an exorbitant amount of money. It's ridiculous. It's dumb. So anyway, that brings me to the case in point. The case being that we're doing Godot, which is an open source. It's open source like Blender. I think they do still have some kind of monetization thing, but it's like for legal reasons. I'm not sure. Like to publish through them, you still have to do something financial, but I think it's a very similar process to the way that Unity should be working, rather than the way that Unity currently is working, if that makes sense. I just got a text message. I did not. I just got a notification saying that people are liking on Blue Sky and on Mastodon. If you are on Blue Sky or Mastodon, first off, thank you for following me and seeing this. That super helps. But also make sure you subscribe, because it super helps the channel. Okay, so cover a couple more bases real quick and then we'll get started. Most importantly, I'm sorry, I keep on making the music cut out because I forgot that I don't have the one music channel on this. I only have it on the main. Whatever. I love you all. Thank you for being here and paying attention. Real quick, thank you so much to my coffee supporters, Vegasar, Starry-Eyed Prince, as well as Cora. Your support means the world to me, and it's just super awesome that, you know, people are actually financially helping me on this journey, which I really appreciate. If you would also like to help out, you can go to the coffee down here. It's right underneath our little burb. Pap, pap, pap. Yeah, and you can buy me a coffee, and every little bit helps. I think if you buy me a coffee, you can also do text-to-speech, so have fun with that. And the closer we get to this goal of just making $100, which is a huge mountain to get over for me, I'm going to get a maid outfit, and I'm going to wear it on stream while playing a dating sim game with Jessie, my partner. It's gonna be a good day. It's gonna be awesome. So now let's get to what's actually going on today, shall we? No more beating around the bush. Let's get right to it. So, I don't know how to script. I'm an artist. So, it turns out that Godot actually has a course that you can take to learn GD script. So today, I'm going to be reading through this with you guys, interacting with you whenever you type and message, and we're just going to have fun. Like I said, I don't know if this stream's going to do well. I don't think it's going to do very well. I think it's going to do worse than most of my streams. But I don't care, because I want to learn GD script, but I also want to hang out with people while I do it. So that's what we're going to do. All right. So what are we learning right now? Right now we're learning about functions. We're learning about how to drive functions, and we're using things like their parameters. We're trying to make this turtle move. So how to define your own functions. Let's break down how you define a function. A function definition starts with the funky as hell, keyword, followed by a space, and the function's name, parentheses, and a colon. There you go. There's an example. Function, space, name, colon. Well, parentheses, colon. I like this song. This is a good song. Oh yeah, it's gonna be even worse too, because again, I'm not on my medication right now, so my ADHD is crazy right now. It's gonna be great. The instructions inside the function must all start with a leading tab character, so that's why it has a little boop boop line. You can insert that tab character by pressing the tab key, but it should add it automatically. We call those leading tabs indents. They're important. The computer uses them to know which instructions are part of the same code. You can also use multiple indents by, sometimes you have like if statements, and the if statements get indented again. So first the function gets an indent, and then all things that are driving other stuff get another indent. It's very interesting to look at. I know all this stuff. Most of this stuff I'm pretty good at. Watch, I'm gonna get this question wrong. Why do we use functions? Select all that apply. To run multiple instructions in one go, okay. To put a name on multiple lines of code. Put a name on multiple lines of code. Oh, I see, okay, yes. To reuse code multiple times. I'm pretty sure all of these. Let's go. Functions are groups of instructions we reuse every time we call the function. Because we give functions a name, they also allow us to name a set of instructions, which is handy. Handy. Names in code have rules. Function identifiers cannot contain spaces. In general, names in programming languages cannot contain spaces. The computer uses spaces to detect the separation between different keywords and identifiers. Instead of spaces, in GDScript, we use an underscore. You saw this already with functions like move forward or move local x. This is convention we follow in GDScript. There's another convention programmers use in some other program languages. Instead of using underscores, they start words with capital letters except for the first one. With that convention, you'd write function names like move forward or move local x. Identifiers also have to start with a letter or an underscore. You can't begin with a number, but you can use numbers after the first character. Interesting. Which of the following names are valid function names? Select all that apply. Note that it's fine to just use capital letters. Okay. Jump is fine. Move forward is fine. Make 3 new characters is fine. That is not fine. 45 degrees can suck it. Move forward is not good either because it has a space. Get out of here with that shit. You can't name functions move forward because it contains a space. Names in code cannot contain spaces. They can't start with numbers either, which is why 45-degree turn is also invalid. However, having numbers elsewhere in a function name is fine. That's why make 3 new characters works. Fantastic. My tummy hurts. Why does your tummy hurt? You should have tea like me. Tea makes everything better. Instantly moving the turtle to a different position in order to draw multiple squares in different positions, we introduce a new function for our turtle to use. The jump function picks up the turtle and places it relative to where it is. So calling jump -150 moves the turtle by 100 pixels to the left and 50 pixels down without drawing any lines. Cool. Function, draw 3 lines. Move forward 100, jump -150, move forward 100, jump -150, move forward 100. Boop, boop, boop. Nice. Let's practice. Okay, let's see. A function to draw squares. The goal, code a function named drawSquare to draw 1 square of length 200 pixels. The function should take no parameters. Use the move forward and turn right function to instruct the turtle. In the following practice, you'll use the drawSquare function to draw multiple squares by calling your own function. Okay, so draw _square. Excellent. Cool. Bump. Cool, cool, cool. And then we're just going to do a move _forward. And then inside of here, what size did it say? 200. Okay, so 200. And then we're gonna turn turtle. Turn right. Or 90. So we're drawing a square. Move. There's an easier way to do this. Like tell it to just repeat this 4 times, but whatever. It's fine. Yeet! Nope. Don't be like me. My brain literally was like, how many times do I have to write this in order to make a square? 4, Andrew. 4. Obviously. Right. Right. All right. Okay. 90. One last time. Move _forward. 200. Okay. That should be fine. Run it. What did I do wrong? Draw _. Oh, yeah, no, draw square. Error, unexpected token, identifier. Oh, I have to write func. Duh. Run it. Boom, 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 boom. Let's fucking go. You never told me why your tummy hurts. Okay, so you have a function to draw 1 square. Draw a square. Use it to draw a square. We already created a draw square for you. Create a function named draw 3 squares that calls draw square 3 times. If you just call the function, all 3 squares will overlap. To stack them diagonally, call jump 300 to 300 between 2 calls to draw a square. Okay. Calling jump 300 makes the turtle jump by 300 pixels to the right and down. Okay, cool. Solid. So, now that we have the space, we're going to do bonk. Draw _3 squares. Okay. And then inside of that, we are going to do draw square. I think you still have to call it like that though. But I think we can do a space or an enter. No, either from lunch or from coffee. There's so much grumbling. Oh, I'm sorry. That's no fun. Okay, so now that we've done that, we'll do a jump. And that'll be 300, 300. Oops. Okay, that should be fine. And then draw square. I would like to say that I like it better whenever Godot and other programming languages already autocomplete, like they would recognize that I'm typing in draw. So since I have a function called draw3, that should show up, and because I have a function called draw square, that shows up too. But no, this little homework project doesn't do that. I don't know if I need to end these with colons. I don't think I do. I think that's correct. Let's run it. Nah, and then jump. Meh, 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 meh. Yay, it worked! Let's go! Skill. What a smart turtle. Lesson complete. Stay and revisit the study material or continue. I'm good. I understand what I'm doing. I'm a genius. Your first function parameter. In the previous part, you created a function to draw a square of fixed size. The function is a bit limiting. Instead, it would be much better if we had a function to draw a square of any size, or better, any kind of rectangle. A square is a specific kind of rectangle. Is it though? In previous lessons, you used the rotate function and gave it an argument. Rotate 0.5. Yep. Just like rotate, we can also give our function parameters. Parameters are labels you give to values passed to the function. Okay, can I rotate in both directions? The radians can be a positive or a negative number, which allows you to rotate both clockwise and counterclockwise. Nice. For now, please focus on the first line, func rotate radians. When you call rotate 0.5, the computer binds the value 0.5 to the label radians. Wherever the computer sees the identifier radians inside the function, it replaces it with 0.5 value. Okay. Sure. The parameter name is always a label you use to refer to a value. The value in question can be a number, text, or anything else. For now, we'll stick to numbers as we have yet to see other value types. What is a function parameter? A number you use to make calculations. A label you give to a value the function receives. The name of a function. Give to a value of the function. I think this one. Yeah! Parameter is a label that represents a value. The value in question can be changed. It depends on what you put in the parentheses when calling a function. How to create a function with parameters. Blech. You can give your function parameters when writing its definition. The line starting with the func keyword. To do so, you add a name inside the parentheses. So, for instance, function draw square is based off length. You can give parameters any name. How you name functions and parameters is up to you. Just remember that names cannot contain spaces. To write parameter names with multiple words, you need to use underscores. The following function definition is exactly equivalent to the previous one. Function, draw square, slide length. Okay, that's fine. Parameters make your code easier to reuse. Here's an example with a function to draw any square. Use the slider to change the value passed to the function and draw a square of different size. So, function, draw square size. Move forward size, turn right 90. Move forward size, turn right 90. Move forward size, turn right 90. You get the point. 40 is the current number, okay? But we can make it fucking huge. Yeah! Okay. Which is the correct syntax for a function definition? Func, function name, Parameter name. That's... Yeah, it's this one. Yes. Yeah, no, that's it. Yeah. To define a function, you need to start with the func keyword. I love that we got lots of func in here. It's good. Followed by space, the function name, and optional parameters inside parentheses. You must end the line with a colon, which most things do end with a colon. That was a poop joke, which defines a new code block. We'll see moving forward that keywords other than func require a colon at the end of the line. Functions can have multiple parameters. You can use multiple parameters in a function. In fact, you can use as many as you need. To separate the function parameters, you need to write a comma between them. Func, space, name, parameter 1, boop, parameter 2, boop, and so on and so forth. Okay. The following example defines a function that uses two parameters to move an entity on both the x and the y axis. Func, move local xy, offset x, offset y. Move local x, offset x, move local y, offset y. Okay. When defining a function, parameters are mandatory or optional. I'm pretty sure they're optional. You can define functions with or without parameters, depending on your needs. I'm so smart. What's the correct syntax to define a function with multiple parameters? Func, function name, parameter 1, parameter 2, okay. Function name. Oh, what's the difference between those two? Oh, there's no comma. Okay, so this one then. Yeah. Always write the function parameter inside the parentheses. To define multiple parameters, you separate them with comma. Let's go. Before we create a rectangle of any size, let's first see how we can use parameters to draw simpler shapes. Here we have an incomplete function that will draw corners with lines of any length, but it's missing its length parameter. The function will move the turtle forward an amount defined by the parameter length. Turn 90 degrees, then move forward length pixels. Complete the draw corner function so it uses the length parameter to draw corners. Length. Move forward length. Move forward length. Run. I mean, I didn't put a jump in there, but I guess they decided to. Well done! In this practice, we'll improve our draw corner function so the angle can also vary. Add the angle parameter after the length parameter in the draw corner function, and use it to draw corners of varying angles. So we do length, comma, angle. Are you my angle or my daemon? Oh, that's not what I meant to do. There we go. Run. Let's go! We have a function to draw squares of any size. We could use these squares as outlines when selecting units in a tactical game, as a frame for items in an inventory, and more. Create a function named drawSquare that takes one parameter, the length of the square's sides. The turtle should face forward or towards the right when starting or completing a square. Be sure to call turn right enough times for the function to do so. Okay, gotcha. Let's go func. We're gonna call this drawSquare. Square. Okay. And inside this, we're gonna call length. Sweet. Then we are going to do a move forward length. Rotate 90. Move, well, here, we'll just do this just to save me time. Copy. V. Oops. One, 2, 3, 4. So that's going to move forward turn right. Move forward, turn right. Move forward, turn right. Move forward, turn right. Okay, run. Where did it go? Oh, turn right. Sorry. We need to call turn right. I thought it was the rotate function. I forgot. Run it. Hell yeah. Let's make our square drawing function more flexible to include rectangles of varying sizes. The job is to code a function named drawRectangle, okay, that takes two parameters, the length and the height of the rectangle. The turtle should face towards the right when starting or completing a rectangle. Note that we could still draw a square with drawRectangle by having length and the height value the same. Okay, so we're going to do a length and a height. And this is going to be length, if I can spell. Wow, I missed it twice. Good job, me. And that's not where it should go. Ay, ay, ay. Length. Height. Length. Height. Run it. Let's go. Should be right. Yeah, continue. Lesson complete. Crushing it right now. Check real quick. The real hope is that we can get at least good enough at, coding that at some point I can do a stream where we just do game development and I don't have to, constantly be looking at tutorials. That would be lovely. Introduction to member variables. In this lesson, we take a first look at variables. In games, you need to keep track of many values that change over time. The player's score, every character, enemy's health, last checkpoint, and so much more. You need to store, retrieve, and update some values. We call those values variables. Variables are labels you use to keep track of values that are over time. Values that vary over time. There we go. Here's an example of a variable tracking a character or monster's health. Variable health equals 100. The line above defines a new variable named health and assigns it a starting value of 100. That's what the equal sign does. More on that below. Function parameters, which you saw in the previous lesson, are another example of variables. In this lesson, we start using variables built into Godot. They're a particular kind called members variables. Members variables are values attached to a game entity. They're useful properties like the position, rotation, and scale of the character. In a previous lesson, we saw how we could use the rotate function to rotate our character. Run it! Run it! Keep running it! Okay. This function increases or decreases the value of the entity's rotation member variable. Say we want to reset the rotation to 0 and make the character upright using the rotate function can prove difficult. You need to know the character's exact current angle to cancel it out. It's much easier to use the member's variable rather than the function. The following code assigns the value 0 to the character's rotation, resetting its angle and making it upright. Rotate equals 0. Run. Nice. Notice how we use the equal sign to change the value of a variable? What's a variable? A decimal number, a label you use to keep track of a value that can change, a function that varies over time. A label that you use to keep track of a value that can change. You're right. Variables are labels you use to access values that change over time. You can also use them to put a name on a value you want to reuse throughout your code. It makes your code easier to read and to change. Accessing subvariables with the dot. In video games, you will see many member variables that have subvalues. For example, the position we mentioned has two coordinates, x and y. It's the same for the scale. It has x and y subvariables. They respectively control the horizontal and vertical size of the game entity. To access those x and y subcomponents, you add a dot after a variable name. What? Oh, I see. Okay. The code below places the entity at 200 pixels on the x-axis and 250 pixels on the y-axis. Okay. Hey. Do it again. Oh, I guess you can't because he's already there. Notice how we use the equal sign to assign the number to the right to the subvariable on the left? Unlike in math, in computer programming, the equal sign does not mean is equal to. Instead, it means assign the result of the expression to the right to the variable on the left. We assign values so often in code that we prefer to reserve the equal signs to that. Yeah, I think you have to do what equals equals in order to actually make it equal something. Or find out what something equals. In games, the y-axis is positive going down. Note that in games, assuming your character's position starts at 0, 0, the code above moves the entity 200 pixels to the right, 250 pixels down. In math, the y-axis is generally positioned going up by convention. The convention is the opposite in video games and many computer applications. The y-axis is positive going down. Why does the y-axis point downwards? This may be confusing if you only saw the y-axis pointing up in math classes. However, in math, axes go in any direction. They don't even have to be perpendicular. On a computer, the position 0, 0 happens to correspond to the top left of your computer screen. It then makes sense for coordinates to be positive when going towards the bottom right corner. This leads to another question. Why is positive 0 the top left of the screen? This is due to the computer and TV display history. They would calculate display pixels starting from top left corner and moving towards the bottom right corner. Let's look at one last example before moving on to the practice. The following code makes the character 1.5 times its starting size. Function, run. Scale.y is 1.5, scale. Oh, I got that backwards, but yeah, okay, 1.5. Couldn't you just do scale equals? Why do you have to do x and y? Wouldn't it affect both equally if you just had one called scale? How do you access subvariables? Variables often hold subvalues, like the position has two subvariables, x and y. How would you access the x, for example? You write a dot between the variable and the subvariable name. You write an arrow, nope, it's the dot. Submit! Trying to confuse me? To access a subvariable, you need to write a dot between the parent variable name and the subvariable name. For example, to access the x subvariable of the position variable, you'll write position.x. In a future lesson, we'll explain why and how these variables have subvariables. For now, just know you can use the dot to access them. We'll tell you which variables have subcomponents and what their names are. In the next lesson, you'll create your own variables and do operations on them, like a doctor, to add or remove, score, or health. You name it. For now, let's practice accessing variables. Maybe we will. Okay, draw a rectangle of 200 by 120 pixels at the x position of 120 pixels and y position of 100 pixels. What? You need to replace the number in the code editor to draw the correct rectangle. Rectangle size is 200 by 120. Rectangle starts at 120 by 100. Okay, I think I see. So it's going to start at 120 by 100. And then the draw rectangle is going to be, yeah, 200 by 120. I'm pretty sure that's correct. Run it. Let's go. Most of this stuff is easy, and like, I know this stuff, but what else? Okay. Draw 3 squares of size 100 by 100 that are 100 pixels apart on the horizontal axis. There should be a 100 pixel gap between 2 squares. You should draw the square starting at the position 100, 100. This means you should position the first square at 100 on the x-axis and 100 on the y-axis. Remember, you need to use the equal signs to change the value of a variable, like the turtle's position. Write your code inside the run function, okay, so the computer can recognize it. Use the provided draw rectangle function to draw each square. 3 squares. First shape is at First shape is at 100 by 100 shapes, 100 pixels apart. Squares are all 100 by 100. Size. Okay. So we want a variable called position that equals 100 by 100. I feel like I've already lost the plot. I need a hint for this one. As each square is 100 pixels wide, to separate them by 100 pixels, you need to move the turtle by 200 pixels in total. I'm aware of that. You need to change the turtle's X position before drawing each square. Okay. Draw the square starting at position 100 by 100. I feel like I just forgot everything that we just did. Because I'm pretty sure this is not correct. This does not feel correct. We're going to use the equal sign to change the value of a variable, like the turtle's position. Write your code inside the run function so the computer can recognize it. Use to provide draw rectangle. I'm going to run it, and it's going to tell me that's wrong, but that's okay. Run it. Okay. And drawing multiple rectangles at line 2. Okay. Error. Expected end statement variable got dot instead. Is there when you write something? Isn't that how we were establishing where X and Y were? Is that not how we were establishing where X and Y were? Clearly not. Shows position 200 pixels. Right. Void, draw rectangle. This is exactly why I'm learning this, because I'm so garbage at code. My God. How did it all leave my brain? Because if I do this... Oh, the method draw rectangle isn't declared in the current class. Is it not? Yes, it is. But it is. I'm so lost. Hint 1. As each square is 100 pixels wide. Well, that's not important to me right now. The method draw rectangle isn't declared in the current class. It is. You're telling me to use it right here. Okay, let's not worry about that then. Just run this. Squares are all 100 by 100. Good. Okay. I think I maybe understand. Okay. So I was close.
Here we go.
$300. Okay. Run that. No, it's still mad. Thunk run. Draw underscore rectangle. Missed so much. I've actually coded the entirety of the universe. I think it's that we don't need these. Run. I missed an N. Okay. They need to be separated by 100 pixels. Which should mean that this is actually 300. Whoa, 300. And this is 500.
Invincible.
There we go. We got there eventually. You bite the inside of your cheek. I hate that. Hopefully you fix a few bucks. Oh no, sorry. I actually made that more frequent. I increased the percentage chance that that happens. My bad. I mean to. Define your own variables. Except I might take a quick break because I have to go to the bathroom and I kind of want a snack. So I'll be right back. I'll be right back. I love you all. my god, I got this great snack. Spicy sriracha flavored peas. They're so good. They're probably too crunchy though to be eating during stream, but I also have Trader Joe's Winter Wake Up Tea. Ah, very nice. Okay. Let's see. See how big the crunch is on the mic. Sriracha peas. Oh. Well, I was hoping the autofocus was going to grab this, but it didn't. They're really yummy. They're super good. I'm really liking it. They're just too loud, I think, to eat on stream, because, like, yeah. Very good. I hear no crunch. Excellent. Defining your own variables. In the previous lesson, we used a predefined member variable named position. In your projects, you will need to define your own variables. Imagine that you need to track the player's health in your game. They may start with 5 health points. Sorry. When taking a hit, the health should go down to 4. After another hit, it should be 3, and so on. To keep track of that, you can create a variable named health, in which you add and subtract points. The example below introduces the print function, which outputs its argument to the output box on the left. Click the Run button to instantly run the entire function, and click the Step button to execute lines of code one by one. The debugger panel at the bottom shows the current value of the health variable. Health is 5. Health equals health minus 1 equals 4. Print 4. Nice. Okay. Ah, so good. All right, I wanted to try something. That didn't do anything. I set up a system the other day where you should have points. It's not working. Oh, well, yeah, all of my commands are gone. Reamer bulk. Add-ons. Yes. Okay. Okay, and then we want this one to be on. I want this one to be on, I believe. And I guess we could also do this one? Sure. Save. Giggle. Alright, now. Okay. Interesting. You're going to gain points by just being here. And then I'm eventually going to make a system where you can redeem points. I don't think there's currently a help. You can't, there's no help that you can get. Eventually, maybe. There's no help for you. Defining a variable. Use a variable. You must first define it so the computer registers its name. To do so, you start a line code with the variable, or the var keyword, followed by your desired variable name, like func stands for function, var stands for variable. Variables are case sensitive, which means health and health are technically different variables. Be careful to use the same capitalization whenever you refer to the same variable. Or you could be reading or writing a different variable. The following line defines a health variable pointing to no value. You can think of it as creating a product label you have yet to stick onto something. Var health. Like with functions, a member variable name must be unique inside a given code file. Creating two variables next to each other with the same name will cause an error. Choose a variable you want to assign it a starting value. You can do so using the equal sign. This code assigns the value 100 to a new variable named health. Var health equals 100. After defining your variable, you can access its value by writing the variable's name. For instance, function run, then variable health equals 100, so health is now 100, print health, which is 100. Boom. Solid. Ignore real previous Thank you. It's not chatbot. It's just a simple line of giving you guys points. I want to see what Stillery's points are, because aside from you, Stillery probably is here the most. Surprisingly, Stillery hasn't been here though in like multiple streams at this point. This tea's really good. God, I love tea. I'm just rocking snacks right now. It's the easiest way to learn. Oh, so once you define a variable, you can change its value anytime with the equal sign, which we knew. So function run, variable health equals 100, health equals 50, print health. It's going to print 50. About the print function. I don't need to know about the print function. It's easy. It just sends whatever it is that you're writing into the command line. And generally, the first function you learn, because yeah, then you do hello world and courses. It sends prints the message or value. You give it to some output window, often a black window with plain white text. Programmers often use print to quickly check the values of the variables when their game runs. In the app, we made a special output window that capture calls the print and displays card to make it friendly for you. Run! Hey there. Hi. Here the verb prints, or print, means to send information to display on the screen. The function prints things on your computer display. It does not relate to printers. Variables are like labels. As we hinted above, in GD script, variables work a bit like labels. Assigning a value to a variable is like taking your label, the variable, and sticking it onto some item, the value. Like a supermarket has a database of product labels, the computer keeps a list of all variables in your code. Given the variable name, the computer can look up the attached value. It has an important consequence. In GD script, you can stick that label in any other value. Stick it where the sun don't shine. Okay, so function run is just gonna run. Then we make variable health, which has the value of 100. Then health equals, this is some text, print health. So this is going to overwrite the 100, and it's instead going to make it the text, this is some text. Yeah, it's because this came second. So that's the new most important thing. The above code is like taking a label from the appropriate item and sticking it to the wrong thing. At line 2, the health variable holds a number. From line 3, health holds text. The computer will let you do that. The code syntax and grammar are correct, but it's not good. Variable name should describe the value they contain, so a health variable with a text value will confuse your future self and other coders. Ha! Joke's on you, nobody wants to code anything with me, look how bad I am at it. It can also cause errors in your game. Later on, we'll see how to avoid the issue of variable types. For now, let's practice creating variables. Yeah, because eventually we'll be able to like call it an int. It can be an integer, and then it can only be a number after that. In this case, it's an integer to start, and then it turns into a string. I know things. I just don't know many things. Define variable name health with a string value of 100. Oh, with a starting value. See, I was about to confuse the crap out of myself. Okay, cool. So we're going to make a variable. We're going to call it health. And it's going to equal 100. Run that shit. Sometimes you just gotta dab. I've learned that the easiest way to stay motivated is to dab every so often. If anybody's coming over from Blue Sky, thank you so much for being here. I'm really loving Blue Sky, and if you don't know, the game dev community over on Blue Sky right now is like awesome. I don't know if it's just because it's like a new platform or something, but everybody's so nice. Everybody's talking to each other. Like, if you're a game developer and you're not on Blue Sky yet, you should go to Blue Sky because it's awesome. The community has just been so great. Anyway, our character in our game will have health by defining the health variable. The higher the character's health, the further away the player is from losing the game. Health that changes adds tension to the game, especially if the player is fighting with low health. It's a resource that the player should manage carefully. The character's health might get low if an enemy attacks them or they fall into a hole. We can create a function to represent damage in these cases. Function: take damage, amount, health, minus equals amount. Oh, and this is super nice too, because this way, since it's not a solid number, literally amount can be whatever we get from the thing that attacked us. Nice. Take damage. Take it. Ah! Take more. Go into the negatives. Oh. Oh, the desire to just sit here and click forever until it hits like negative 9,000 or 9 billion, whatever. Anyway, we pass the amount of damage the robot should take as a parameter. Line 2 subtracts amount from health. Note that minus equals syntax which achieves this. It's the shorthand we often use. You can also use a longer form. Both of these lines have the same effect. They both subtract values of amount from the health variable. Health minus equals amount, or health equals health minus amount. That makes sense. You may notice that the health of the robot can go below 0. We'll see how to manage this in the future lesson using conditions. The robot's health could increase instead if the player picks up an item that heals them, or if they use a healing item, which is plus equals instead. I love it where my health bar goes off screen. That's extremely helpful, especially during Dark Souls games. Here, again, the health can go beyond 100. Also, oh, I'm gonna sneeze. Oh, I'm gonna sneeze. Oh no, it's gone. Oh, it's gone. Okay. Also, once more, the short line health plus equals amount is equivalent to the longer form health equals health plus amount. Which of these would increase the health of the robot? Select all that apply. Health equals health plus amount. That would do it. Health equals health minus amount. That would not do it. Health plus equals amount. That would, and that would not. Submit! In the following practices, you'll code the take damage and heal functions so the robot's health can decrease and increase. Let's do this! Okay, so, in our game, the main character has a certain amount of health. When it gets hit, the health should go down by a varying amount of damage. Add to the take damage function so it subtracts the amount to the predefined health variable. The robot starts with 100 health and will take 50 damage. Ooh, sorry, buddy. Guess you're gonna take 50 damarinos. Run it. Oh. Wait, I did. What? What? Oh. Amount. Sorry, amount. Run it. There we go. I did it directly. I was supposed to write amount. I don't like that they don't also write down variable amount equals 50, because that makes it confusing. Like, if I clearly saw that there was a variable inside of the code that was called amount and 50, then my brain would be like, oh, cool, I can use that variable in this code. So them just not having it is really confusing. It's time to heal a robot up to full health. Write a function called heal. Okay. Got it, boo. That takes amount as a parameter. Okay. Solid. The function should add amount to health. Okay, so health. Oh wait, I fucked up. Plus equals amount. The robot starts with 50 health and will heal 50 to get. Okay, run. Run. Oh, bunk. Run. Okay. Amount. Run. Yeah, okay. We got this. It's all good. Lesson complete.
I'm on my own, broken alone. I feel the rain crashing down all around this empty town. I'm searching for the lost and found, but you don't care, you're unaware. Keep moving like the scars aren't even there. It's in the air like a blazing flare. Just stare 'cause the flames will burn us. I thought you were the one for me. That's why I gave you everything.
Sorry, it was snack break time. Snack. Oh, but they are a little spicy. Ah. Sorry, they're spicy. They're not all spicy. It's just sriracha, like, They're not that hot. I need to stop snacking. Okay. The game loop. As we've seen, Godot has functions that do certain actions. For example, the show, boink, and hide, boink, functions change the visibility of things. We can also create our own functions to make custom effects like adding or removing health on a character. Godot also has specific functions we can customize or add to. Take the process function. Process delta, rotate 0.05. Sorry. The underscore process blinks function gets its name because it does calculations or continuous actions. It's like a juice factory that processes juice bottles. The bottles are always moving along a conveyor belt while different machines operate on them. It's similar to Godot, but this function can run hundreds of times a second. How many parameters does this function take? 1. The process function takes 1 parameter delta. We'll look at what delta is in the next lesson, as well as show how to use it. The process link function won't do anything until we add something to it. You might notice the underscore in front of the function name. This is a convention programmers use to coordinate work. And it'll only make sense once you have experience coding in Godot. Well, that's what I'm trying to get. For now, all you need to know is that if the function exists in your code, and it is called precisely underscore process, then Godot will automatically run it every frame. Really? When Godot draws on the screen, we call that a frame. Okay. Is this the same for other engines? Other game engines might use different names, like update. Why is the underscore process function useful? It's perhaps better to see the process function in action. Function underscore process delta rotate 0.05. Whee! He's a spinny guy. When you click the button set process, you activate its trap card process on the robot. From there, every frame, Godot runs the underscore process function. Since we wrote rotate instruction, Godot is rotating the character by 0.05 radians many times a second. How often does the process function run? Multiple times a second, once a second, multiple times. It's more accurate to say once every frame, but whatever. The faster your computer, the more times underscore process will run. Godot will try and run underscore process as quickly as it can. This makes sure any movement or animation looks smooth and fluid. In the practice, you'll learn how to use the process function to rotate and move a character yourself. Which makes me think, sorry, this is going to be happening probably throughout, but that makes me think that if I want this to work, then I need to do func underscore process and then I can get the distance between the controllers. That's right. The problem that I'm having right now is I don't know how to tell it to look for the controllers. Print. Q. Well, I have to do this. Q. Which means that every single frame it should write Pew. Parent signature. Interesting. I don't even know what that means. Okay, well, we still don't have enough information to solve this code problem that I'm having. To practice, you'll learn how to use the process function to rotate and move a character yourself. Practice! Make the robot rotate slowly by adding to the process function. Okay. Rotation speed of about 0.05. Each frame should do it. So, rotate. 0.05. Whoops. Run it. All right. Make the robot move in a large circle slowly by rotating it and simultaneously moving it along its X direction. To do this, add the rotate and move local X function to process. Okay. 0.05. I think it has to be 0.05 though. And then move local X 5. Run it. Whee! Look at him go. Lesson complete. Sarah's at study. No, I'm good. Time delta. Time delta, not time. It just means that it's going to make this flow in seconds and stuff, and it will no longer be based off of the frame rate of the computer. I'm doing good. What time is it? Man, time flies. It's already been an hour and a half of doing this. That's crazy. Yeah, literally, the VR game that I'm working on right now is why I was like, I need to like just do lessons. I have to, because I have been struggling so much, and it's mostly just because like I don't understand the fundamentals of programming. So even though I know kind of what I'm supposed to be doing, you're doing well. Superman does good. Yes, sure. Yes. I am doing well, you're right. I do good. I provide a service. I entertain. It's the same thing. I'm basically Superman. That's what everyone says. I'm losing my mind. But yeah, so I was trying to just, you know, smash my brain into my VR game. And I was like, I know a little bit of code. Like, I could probably get it to do what I need it to do. I can't. I've gotten so many errors that it is disgusting. It's disgusting. And I don't even know why. Like, I feel like I'm doing it correctly, but I'm clearly not. So, that's why we're here. Trying to figure this shit out. Because I just need to build up my base. Once I understand programming, at least to a degree, then we'll be good. Woo! Okay, but I'm going to take another really quick break. So, un moment. So we have to get through this. This is going to be the painful part, is just learning programming as best we can. And then I could actually start doing what I want in VR, hopefully. I don't like this song. Skip it. I don't know why that hasn't been working lately. I used to just be able to change songs by swiping, but it doesn't do it anymore, and I don't know why. Okay. Let's go. Time Delta! We've seen how we can use our character's process function to make it move continuously. Function process delta rotate 0.05. Whee! But it's not just our character that has a process function. Almost everything in a game has a process function. Dozens of times per second, Godot runs every process function in the game to update the game world. After that, it displays an image of the game world on the screen. We call that image a frame. Godot then moves on to calculating the next frame. As this happens dozens of times per second, you get the illusion of movement. This is similar to how traditional animation works. This sounds like frames per second. You may have heard of frames per second, or FPS for short. Games often run at 60 frames per second. It means that everything in a game updates 60 times each second. The number varies while playing depending on the game and the device it runs on. On powerful computers, you may get frame rates in the hundreds or thousands of frames per second. Let's look at the process function in more detail. What parameter does the process function take? Func process delta rotate 0.5. What parameter does the process function take? It takes delta. Process function has one parameter named delta. Frames take varying amounts of time to calculate. Depending on the game, the computer, and what the game engine needs to calculate, frames take more or less time to display. There will always be millisecond variations from frame to frame. That is why the process function receives a delta parameter. Delta represents a time difference. It's the time passed since the previous frame in seconds. We can use it to ensure that the changes between frames don't make the game's behavior unreliable. This is because different computers run differently, so fast computers will have more frames per second than slow computers. If we ignore delta, the game experiences will vary depending on the computer. Delta helps to make the game experience consistent for everyone. What do we know about delta? Select all that apply. Its value in seconds. I think it is. Wait, I just read it. It's a value in seconds, right? It's the time it took Godot to complete the previous frame. It varies each frame. It does not vary each frame. That's the point of delta. I don't think any of these are true. It's a value in seconds. It's the time it took Godot to complete the previous frame. It's not that. It's value in seconds. Value in seconds. It's the time it took Godot to complete a previous frame. It varies each frame. That's all of them, okay. Delta is the time it took Godot to complete the previous frame in seconds. It's very small because frames happen many times a second. It varies each frame because Godot needs to process more or less each frame. Multiplying by delta, the delta you get in process, is a time difference in seconds. It will generally be a tiny decimal number. To apply delta, you need to multiply your speed values by it. So, time.delta time is what I always think of. I'm sure time.delta time is something different, but I always think of that. Function process delta, rotate 3.0 times delta. Whee! The delta you get in process, the time difference in seconds generally. To apply delta, you need to multiply your speed value by it. When multiplying by delta, you make motion time dependent rather than frame dependent. That's essential to make your game consistent and fair. Why do we use the number 3.0 in this example? At the top of the lesson, we made the robot rotate a fixed amount every frame, 0.05 radians. In the example above, we now multiply the argument by the very small delta value, a value way below 1.0. It makes the robot turn at a constant speed over time. However, multiplying by a number below 1.0, like delta, makes the result smaller. To compensate for that, we make the robot turn fast enough, we use a larger number than before, 3.0 instead of 0.05. These numbers are two different units. 0.05 is an angle in radians, while 3.0 is an angular speed in radians per second. When you multiply speed by a time delta, it gives you an angle. Don't worry if it's a little confusing for now. It'll eventually click as you deal with speed, acceleration, and motion in your game projects. Why the time between frames matters. The time it takes to display a new frame varies. If you don't take the time into account in your code, your game will have gameplay issues and bugs. Godot provides that time to the process function through the delta parameter. In the example below, the top robot moves using delta. As a result, it moves at a fixed speed. The bottom robot moves over a constant distance every frame without taking delta into account. It will move faster and slower than the top robot on your computer. Will it? Play. Play. Okay. Multiplying time-sensitive values by delta makes them time-dependent rather than frame-dependent. Thanks to that, we get reliable movement over time. Without delta, frame times vary from computer to computer and during gameplay. Because of that, the movement will differ for every player, making the game inconsistent and messy. What does this mean? Rotation underscore speed times delta. We're subtracting delta from rotate. No. What? No, we're multiplying. Multiplying rotation speed by delta. In the next practice, we'll use delta to make rotation time dependent. Let's go! At the moment, the rotation of the robot is frame dependent. Okay. Add delta to make the rotation speed time dependent. The robot should rotate 2 radians per second. 2 times delta. Run it. Solid. Moving in a circle using delta. In this practice, make the robot move in a smooth circle using delta. To get this movement, the robot should rotate 2 radians per second and move 100 pixels per second towards clockwise. Okay, so rotate 2 times delta. Okay. Then local position dot x 100 times delta. Run. Okay, I fucked up somewhere. Run. Fuck. Oh, underscore x. I think it's that. Was it? I thought it was local position. Please write the values in the parentheses when calling the function. If you define extra variables, we will not be able to check your practice. Move local, not, okay, gotcha. Not local position. Move underscore local. X, run. Whee! Doing a heckin' good rotate. Yes, he is. Using variables to make code easier to read. In this lesson, we'll make our code easier to follow and understand at a glance. Take a look at the example. Function process delta rotate 4 times delta. In the above example, what does the number 4 mean? It's the speed. It's how far the character moves in pixels. It's how long the rotation takes. It's how fast the character rotates. I guess technically it's how fast the character rotates. Code above rotates the character 4 radians per second. We can guess what a number represents by looking at the function name, but it's harder to recall what this number does by quickly looking at the code. We've seen how different functions have their own names. Using these names, communicates to developers what the functions do. Rotate 2 radians. Move local x 100, move horizontally 100 pixels, move local y negative 200, move vertically negative 200 pixels. As we learned in lesson 8, we can also assign labels to numbers to help us remember what they do. We call these labels variables. A variable is a label for a value we can save, change, and read later. Let's recap how to define a variable. Variable space, variable name, space equals space value. We improved the first example to make it clear what the number 4 does. Variable angular speed equals 4. This variable is defined outside the function. Function process delta, rotate angular speed times delta. Labeling a value makes the code easier for us to read now and in the future. In the above example, which line defines the angular speed variable? Which line defines the angular speed variable? It's the variable angular speed 4. If we define variables outside of a function, we can reuse them in different functions. Because any function can use variables we define outside of them, we call these variables script-wide. Script-wide, baby! Here, we use the angular speed script-wide variable in both the process function and the set angular speed function. Okay, variable angular speed equals 4, function process delta, rotate angular speed times delta. Function set angular speed equals new angular speed. Ah, okay. Interesting. We can also define variables inside of functions. We align the variable's assignment by indenting to make it part of the function body. Make sure to create the variable before using it. If we define a variable inside of a function, only that function can use it. Function process delta, variable angular speed equals 4, rotate angular speed times delta. Function set angular speed equals new angular speed. But since that's in a different function, we can't do that. That would throw an error. The angular speed variable only exists inside a process because we defined it there. The set angular speed function can't use it. Trying to use it there will result in an error. Here's what this error might look like. The identifier angular speed isn't declared in the current scope at line 6. Why this happens? The set angular speed function can't use the angular speed variable because it isn't script-wide. It also isn't the set angular speed function. How to fix this? Boop. Make sure to define the angular speed variable in the set angular speed function or define it outside the function as a script-wide function. Brilliant! Where can we define variables? Select all that apply, inside of functions, outside of functions. We can do both. Functions can use variables defined outside the function. These variables are script-wide. If we define a variable inside of a function, only that function can use it. Variables are also great at grouping values that control how a character behaves. Grouping them this way allows you to easily change them. Variable horizontal speed 200, variable jump strength equals 150, variable gravity equals 90, variables for combat, variable health is 40, health maximum 80, so on and so forth. In the following practices, we'll define variables and use them with some familiar functions to make our code more readable. Cool. Let's give the 4 here a label so we know what it does. Create a variable called angular speed outside of the process, a function to make it script-wide. This allows us to use the other functions too. Then replace the 4 with angular speed. Okay. Boop boop. Var angular speed equals 4. Angular speed. Run it. Amazing. Continue. There's something wrong with this code here. Can you see what it is? Run the code and read the error. Correct the code so it works as intended. I'm just going to figure it out. I don't want it to tell me what's wrong. I want to find out. We're trying to get angular speed again here. That is not correct. We're going to rip it out of this. Kill it if you must. We're going to put it outside instead. So it'll be script wide instead. Run it! Haha! Skill. Conditions. In previous lessons, we decreased and increased a character's health, but there was no limit to how much health they could have. Function take damage amount, health minus equals amount. Function heal amount, health plus equals amount. As a result, am I just getting messages? What's going on? Oh my gosh. Alright, continuing. As a result, the player could increase their character's health indefinitely, which we do not want. Hey-ya! There you go, bud. Have as much health as you want. What happens to health when we damage our character? Suppose our character has 100 health. What would the value of health be if we call take damage 25 5 times? Well, if they're at 100, negative 25. Woo, basic math. We can use conditions to run actions selectively. Conditions make your code branch into 2 paths. If the condition is met, the computer will run the corresponding instructions. Otherwise, those instructions will not run at all. Video games and other computer programs are full of conditions. For example, game input largely relies on conditions. If the player presses the button on a gamepad, the character jumps. Jump, 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 jump. When the computer checks a condition that is called to evaluate a condition, all conditions evaluate to either true or false. Either the player is pressing the button or not. Either the character is touching an enemy or not. In our case, if the health goes over a maximum value, we want to reset to the maximum. To define a condition, we use the if keyword and write lines starting with if. Type the condition to evaluate and end the line with a colon. Function heal amount. Health plus equals amount. If health is less than 100, or is greater than 100, then health is 100. Notice the greater than comparison sign. We read the symbol as greater than. We've seen how function definitions use a colon at the end of the first line and nest content inside. In GDScript, the syntax is a recurring pattern for all code blocks. Okay. The computer knows which instructions belong in the condition because they are indented. Gotcha. Heal, 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 heal. Step, 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 step. Comparison. In the above example, we use the greater than syntax to mean greater than. We can compare numbers in other ways too. Greater than means greater than, less than means less than, equal means equal to, exclamation point equal means not equal to. Here's how we might use these in if statements. If health is greater than 100, pass. If health is less than 50, pass. If health is equal to 25, pass. If health is not equal to 7, pass. It just makes it so we don't get an error. The pass keyword prevents errors in our code when a line cannot be empty. For example, we must have a line of code after a function definition or an if block when you don't know what to write yet. You can use the pass keyword as a placeholder, and Godot won't give any errors. In the previous example, if there was nothing below the if lines, Godot would give an expected and indented block after if error. What of these statements are true? Select all that apply. 1 does not equal 3, that is correct. 2 equals 1, that is not correct. 2 is less than 3, correct. 3 is greater than 1, that is correct. 3 is less than 1, that is not correct. Or else. The if keyword comes with a complementary else keyword. You can write an else block after an if block, if like so. Function run variable speed equals 120. If speed is less than 100, print you're slow, else print you're fast. So because 120 is over 100, we should get you're fast. Yeah! The else block will run whenever the condition above isn't met. In the following practices, we'll use conditions and improve the way our character's health changes so it has limits. Very nice. Let's go! Okay. This series of if statements is all wrong. Change the comparison so each comparison matches the instruction below it. Keep the values and statements as they are. Only change the comparison signs. As a reminder, the comparison signs, yeah, I know. Line health means health is less than 5. Yeah, I know. Okay. Health is greater than 5. Oop. If 1 is greater than health, 1 is less than health. Health is equal to health. Oop. Oops. Okay. Health is not equal to 7. Exclamation point equals. Run it. Let's go. Okay. Goal. We have a heal function that adds an amount to the character's health. Add the function so the character's health is never greater than 80. Okay. Health plus equals amount. If health is greater than 80, health greater than 80, set health equals 80. I think that's right. Oh yeah. Okay. Function take damage amount. When the robot takes damage, its health can be negative. We might want to display the health number on screen like in Japanese RPGs. We don't want negative numbers. We want to stop at 0 instead. Calling the function should reduce health by amount. If health goes below 0, set it to 0 again. Okay, cool. So, we want to do health minus equals. Does it matter how much we're subtracting by? Does it say? 20. We'll just do 20. And then if health, if health, if I can spell, is less than 0, then health equals 0. Run it. Why is that wrong? Error. Expression indent block, right. Run it. Health takes different values. What do you mean health takes different values? Damage in character 3 times by 10. Oh, 10 points, my bad. Run it. I didn't realize it was going to get attacked 3 times, but I guess I could have read more and it probably would have said. Hell yeah. Okay. I think that was going to be the end for today because I have to run errands and stuff. I really appreciate that so many people actually watched this stream. I hope these will be more interesting in the future once I, am a little bit better at coding. I'm probably going to keep going with this later in the day, but I'm not going to stream it because I just don't see a point. But we'll see. Maybe I will stream it. Who knows? But the world is my oyster. All right. But I love you all. Thank you so much for watching. If you're new here, please consider subscribing. It really helps out the channel. And if you're really cool, you could join the coffee, which is down here, the bottom left-hand side of your screen. Sorry, Aaron. I have to go and get my medication, which should be ready by now. Finally have my ADHD medication. Woo! Good times. All right. I love you all. I will see you later. Farewell for now.